So she's going to present a digital tool for industry decarbonization, a case study involving the zero industry innovation.
Yes, so first of all, good afternoon. My name is Laraib, and I am, as he introduced me, I am a research associate at Net Zero Industry Innovation Center, which is part of Teesside University. And I'm delighted to present you our case study at Net Zero Industry Innovation Center. It's all about an immersive digital twin for industrial decarbonization. This research has been carried out in collaboration with Dr. Clair Cooper, Dr. Sean Williams, and Dr. Nashwan Dawood. So in this presentation, I would like to show you how immersive digital twins can support industrial decarbonization, not only by integrating the physical assets or operational data, but also by improving the understanding, engagement, and helping us to support in the future decision making. So before introducing you with our case study, I would like to briefly reflect on the evolution of digital twins. So it all started, the main origin of the digital twin can be backtracked to 1960s, when simulations and virtual representation of physical assets started to support the engineering applications. And then over the subsequent decades, with advances in computing, sensing technologies, and integrating data into those early systems, then we got the digital twins that are more modern, because they are not just digital replicas. Because we are integrating data into them, they have enabled us to actually see the immersive kind of visualizations. Also, they helped us for analytics, predictive analytics. And lastly, I would say, of course, decision making. And our research is basically based on this last stage of digital evolution. Yes, so a question comes in mind, like why digital twin for net zero? Because it's a different kind of discipline, you would say. But the thing is, it's really basic to understand that the digital twin for net zero is really important, because net zero transition is not just a technical challenge, but it is a systems challenge, because it involves interconnected infrastructures, multiple stakeholders, and also multiple technologies, and most importantly, the continuously evolving data. So for that, to address this, we have the digital twins, because digital twin provide us the ways to actually bring all the complexities together and help us to visualize those complexities, then integrate data into those complexities, and then have the decision making support. Also, it improves the engagement. So this is basic motivation behind this whole research. So this is our case study. You see here, this is the net zero building. And it's a living laboratory, a unique living laboratory, I would say, where we are actually developing, demonstrating, and evaluating those emerging net zero technologies. And the technologies that we have at net zero are carbon capture, direct air capture, hydrogen, and smart energy systems. So with all these technologies, we can say that net zero is basically an ideal test bed for developing digital twins for these technologies, and help us to actually understand how people are perceiving these technologies. So we have extended our framework with direct air capture. We have selected this as our extended framework, and we have then developed a digital twin for this building, as well as this DAC, direct air capture. You can understand it like direct air capture can actually have a potential to remove carbon dioxide from atmosphere. But the most important thing is, it is really unfamiliar to the most of the wider public, and which poses a challenge to its successful adoption. So to address this, our research actually comes in place, because we are providing people accessible user experiences through our digital twin so that they can engage and also they can explore these technologies and understand these technologies so that they will be able to trust these technologies in future. So we have the digital twin that would be adaptive. So this work is in progress. This is not complete yet. So we are planning to have adaptive digital twin. When I mean to say like adaptive, it means that we are having a digital twin for which our vision is basically to focus on how it will be significantly support operations of this technology, DAC, and also the optimization of the DAC, direct air capture facility. So for that, we have our digital twin have data you can see here because it's a direct air capture and it's capturing, like, for example, it will say we have the data like CO2 concentration. This is basically the operational data that we will be feeding into our digital twin. And then you can see here, this data is temperature, humidity, it could be CO2 concentration, fan speed, etc. So we have this all operational data here, and then we are feeding this data into our digital twin. And we are feeding into digital twin to actually analyze this data and to optimize it for our key performance indicators, which could be like our capture efficiency, energy efficiency, like it could be cost, operational cost. So this is the way we are making it adaptive. I will explore more about this in next few slides. Here is, we are moving towards intelligent digital twins now. So we are planning to have AI analytics layer, which will be having data. So data, from the data, it's a direct air capture or our digital twin will be learning from this data. And this data could be from the multiple data sources like IoT, BIM, operational systems, RGs. So we are actually learning from the data, and we are then moving towards what if simulations. We are having different scenarios. And through these scenarios, we are able to generate these recommendations. Recommendations, what recommendations? I will show you on the next slide. For example, we have the optimization engine in which we are optimizing those operational needs, because we know that optimization is not a one-time process. It should be continuously updating with the changing requirements or operational changes. So for that, for example, let's say the CO2 concentration increases or goes up. So what we will do, our system will actually optimize it in a way that overall system performance remains consistent, and we are able to fix this. For example, we will see the concentration levels. It will have some triggers. It will recommend some adjustments so that we will be able to fix it, for example, in future. So we are planning to have this intelligent digital twin for this net zero building and then this direct air capture. This slide basically is the heart of the whole presentation. Why I say heart of the whole presentation is because it involves, we believe that net zero transition basically involves three main things: people, place, and then technology. For the just transition, it's really important to have all of these. And for the people, we have the people with the understanding of this technology, we will have engagement of the people, then we will have perceptions and acceptance of these technologies. And in terms of place actually brings us the industrial infrastructure, heritage, and also the local communities. And in our case study is basically Net Zero Industry Innovation Center and DAC, which is basically based in Teesside. So in our case, the place is Teesside. Lastly, there is the technology, which is our digital twin, our DAC, BIM, IoT, and all the technologies that are involved in this whole research. With all these dimensions together, we are actually moving towards a digital twin that is supporting the communication and also informed participation in net zero transition, so that people don't feel left behind. They feel like they are involved in this whole net zero transition. Lastly, here are some future works that I have listed. So this is the work in progress, and we are trying to have an enhanced data integration into this digital twin. We are having advanced AI and predictive models that we'll be having in future, and now we have interoperability and standardization, then real-time optimization and decision support, which is the goal, and then lastly, immersive, embodied, and collaborative XR. Thank you very much for your attention, and if you would like to explore this digital twin, this is the initial demonstration video. You can scan this QR code and see the initial video of the digital twin, how it looks like the building and the deck. I'm still live. So, and also to get in touch, you can contact any of us. So this is Nashwan, and this is Clair. She's a social scientist at Net Zero Industry Innovation Center. So our research is more like virtual reality, digital twin, like the technology bit, and then we have the social bit, with which for which the Clair is working on. So that we are seeing like how people are perceiving these technologies and how we'll be able to improve this perception and acceptance of these technologies. Yes, and that's all.
Thank you, Laraib.
I will leave.